Wow, CircleCityCon. Everybody enjoying this all so far? Yeah, woo! Yeah, Nate's still in here. Come on, guys. Show some enthusiasm. Thanks. So I wrote this talk. I originally gave it at a local OWASP meeting. I don't know how many. I know I see a few faces in the meeting that were probably there. But it was. It's kind of a little bit for the defense and a little bit for the offense, or more for the developers and for the offense side. So just a quick show of hands. Do we have any developers here? Anyone who works with software security, product security, anything like that? Yeah, and application security. How about any pen testers? A few pen testers in the crowd? Okay. So basically, I'm just going to talk about the importance of whitelist validation versus blacklists. We're going to show some bypasses and stuff that I've seen that work pretty well, and how you should be doing their coding. So if you interface with developers either as a pen tester to try to talk to them why they shouldn't be doing something and how you got around it, or if you need to work with product security as to how they should be implementing something, that's what this is about. So as Nate said, my name is Damian Profancik. I work for Trustwave Spider Labs. I'm on the application security team, do application pen testing, code reviews, that sort of thing. So as I said, we're going to talk about approaches to validation, input validation, whitelists versus blacklists, and then kind of some techniques I've seen that work pretty well at bypassing some of the protections. So the reason why input validation I think is pretty hard is because there's so many different ways to express data. So for example, that's a program. It's pretty heavily obfuscated, but it basically does that. So it just pops up an alert box. But if you're looking at it, you would be like, what the heck? The other thing that is the problem is that oftentimes programming languages don't do us any favors. So it's really easy for me as the bad guy to go look for ways around something. So as an example, JavaScript. So this is JavaScript array plus array, and what you get with that is you get an empty string, not an array. Array plus object. Anyone guess what you could get with that array plus object? You get an object, okay? Object plus array, guess what you'd get with that? Anybody? Bueller? You get 0. What? So object plus object. How about not a number? What? What about type of not a number? Number. Yeah, go home, JavaScript, you're drunk. So, the other thing that makes this really the hardest part, I think, is because it is so tedious, and you really got to think of all the different ways, and you got to think like an attacker. But it really is the most important part. Almost all vulnerabilities that you're going to deal with, whether injection flaws or logic flaws, they're things you're not validating correctly. And so input validation is extremely critical. Basically, it's the process of verifying that the data that you're getting in is the data you expect versus just trying to find all the bad things in the what you're getting in from the user. You should be looking for like the data type. Is it what you're expecting to use? Is it a number, for example? Is it too long? So this is a result of like your buffer overflows and things like that, or the cause. Is it the right character set? Because that can mess with encoding and things like that and ways to bypass it. And is it in the right format that you expect as well for data sanity? And the other thing too that you see a lot is that developers may not understand what really is untrusted data versus not untrusted data. I just did a pen test on an application that basically once you logged into the application, it created this really big long cookie that contained all these flags like allow data security, allow impersonate user, true, false, all these different things, and they didn't realize I could just flip all the flags to true, and all of a sudden I was God in the system, because they didn't understand that cookies are coming from the user. So there's all these other things like user agent strings. I've gotten SQL injection from user agent strings and things like that, or referrer headers, but also from your database. Just because something is in your database already shouldn't be trusted as it's coming back out of your database or some partner database or some API that you're calling, or you're getting some results from some other application. So it's really, it's every input that you could possibly get into your application that needs to be checked. Really, you need to be asking yourself a couple questions. You know, where is the data going? Well, and what am I going to use it for? And then also, what am I protecting from? So this is your threat modeling. You're looking for what's your attack surface, and what's going to be used for. And then coding is really the you should be used for display level protection. So this is like your cross-site scripting and things like that. You should be using encoding on top of the input validation. So let's talk about some approaches on how you would do that kind of validation, or some approaches I've seen done in the wild, and then kind of escalating from the bad to the best. The first one that I've seen is client-side validation. So they're looking at some piece of data, they're checking it on the client side in JavaScript, for example, and then they assume that once they've scrubbed it or checked it right there, then they pass it along and everything's good. This actually just wrapped up another pen test that they called or emailed me like a week later and were like, hey, we have like $95,000 of revenue that was kind of like clogged up in the pipe because all these back-end jobs weren't running. How did you insert dashes into your social security number field? And they sent me like screenshots of their database and error logs, and it would say like, field too long, you know? Because basically they were trying to scrub all the dashes out and they only had a fixed length on their database field. Because I wasn't sending it through their application, I was sending it through a proxy. And so I could insert whatever I wanted. So obviously they weren't validating on the back end as well. Really, JavaScript and client-side sanitization or checking really is just a performance measure. It should only be, like if you check it on the client side, there's no need to send it on if it's already bad. You already know it's bad, don't send it on. That's just to save packets across the network. But it should also then be checked again once it gets to the server. So encoding, this is another thing that I've seen. After wrapping up a pen test and you found this cross-site scripting, the client goes, okay, I think we fixed it. And I get in there, and sure enough, I mean, it solves the problem, but it looks really ugly because what they're doing is they're encoding it before they stick it in their database. And so you get this pop-up box that has like this, in the strings, like ampersand LT, semicolon, things like that. That's okay for HTML, but the problem is that whenever you're doing encoding, it's context sensitive. You can't just encode when it goes in the database, because when it comes back out, you don't know what kind of context you're going to be landing that user-defined data in, or it could be in multiple places, and there's different encoding schemes depending on where it's going. So all output should be encoded, whether it's coming from a user or whether it's coming out of your database, because again, you don't know necessarily the data could have come into your database from some other application, integrated application or something like that. Or I've also seen it where they say like, okay, we fixed this cross-site scripting, but as soon as I log into an application, it pops again. That's because, yeah, they fixed the input, but not the output. And so the persistent cross-site scripting I already had in the application popped. The other thing too is escaping input. So this is also kind of a good idea, but more, again, escaping should be done on the output side of things. So like JavaScript, for example, there are special characters and SQL that are special to the language, and so escaping those with the special characters. So like, for example, like this is a SQL injection. Oftentimes I see this where they'll double up single quotes. What that means is if inserted into a string, that 2 single quotes is a literal single quote, 1 literal single quote, so you get something like this. The problem is that me as an attacker, if I'm, like, let's say, attacking a MySQL database, well, the escape character is a slash. And so I can escape your escaping, essentially like this, and then the SQL injection works because I've escaped the single quote that you've doubled up on your. Similarly, with cross-site scripting, I see this a lot, where they'll escape single quotes or double quotes to keep me from breaking out of the string, but they forget to escape the escape character. And so I do that, and again, I can still jump right out of the context into JavaScript. Typecasting, this is also something that you should be doing, but oftentimes doesn't. So if I'm dealing with a number, like an ID value or something like that, then you should be typecasting that and making sure that it is a number that you're getting and not a string or it contains miscellaneous characters. The problem is that if the input that you're trying to get is supposed to be a string, then you kind of have a challenge there. Or if the type is correct, let's say a number, but the value is invalid. So for example, a negative value. That happens a lot on shopping cart applications where I can specify negative quantities or negative prices and things like that, and actually get credits, essentially. So that's where you should be validating, not just typecasting. So all these are kind of stacked on top of each other. Another big thing that I see a lot, ASP.NET is actually a pretty good language when it comes to building applications, because it does do a whole lot of things for you. The problem is it does a whole lot of things for you. And it's just like AV, right? So I can be a little bit more reckless because I have AV, right? I can just go to any website I want. Well, no, you still have to be careful because it doesn't do everything. It's not a silver bullet. There, I said it, silver bullet. Also, a lot of browsers do have cross-site scripting protections built into them. However, there's often ways to disable these protections, whether an administrator may be going through their environment and saying, okay, well, for these websites, let's say it's an internal intranet site, disable protections because the coding is really bad and we don't want to fix it, and so we'll just disable our protections because we don't want to have phone calls into the help desk. Or a user might to solve some problem at one point in time. Or protections might not be complete. Maybe there's edge cases or things that the protections weren't even designed to protect you against. And then lastly, there's often ways of bypassing them. There's been proven all kinds of different ways. So ASP.NET, so focus on that again. So who's familiar with request validation? Anybody? All right, one person. So ASP.NET has a nice feature called request validation. What it'll do is look at the parameters that you're sending into it and make sure it's trying to protect you against cross-site scripting. So for example, it's saying look for a bracket, a left bracket, and in any alphanumeric character or an exclamation point or a slash. If you see that, it's cross-site scripting, drop it. Or if you see ampersand and a pound sign, that's also cross-site scripting, drop it. The problem is that really only protects you from post parameters and get parameters. That's about it. If it's persistent, if you found a way to persistently get it into the application, it has no way of knowing that the cross-site scripting was put there by you versus built into the application. So if it gets it back as an output. Similarly, it's not even looking at the HTTP headers. So if you can get it into some sort of HTTP header like user agent or something like that, it's not going to even look at that. If you're landing in a JavaScript context, if you're already in JavaScript, then it's going to be able to bypass that anytime. Or if it's an AJAX call like XML HTTP request, or splitting parameters. So let's say, so it's looking for that left bracket and then any character. If I have two different parameters and maybe it combines them in the output to display, if I put my left bracket in one of the parameters and I put the rest of my payload in another, and when they get combined in the output, then my attack is valid. some while back, this was a pretty valid exploit for bypassing request validation because it wasn't looking for that percent sign. It's gotten pretty crusty. Microsoft's done some good things to try to stop it. So it pretty much died at IE7 as far as the percent sign goes. And then with IE11, I believe, they've also made it even harder that the expression function doesn't work anymore unless you're in the trusted zone. But this still could be a valid attack, and I've seen some scenarios where it could happen. And we'll talk about that where a header is set, and maybe say you're talking about an intranet site. I've seen lots of admins add in their intranet sites into the trusted zone because they want everything to work. This is some pretty awesome hotness, actually. I've been using this a ton for persistent cross-site scripting. Does anyone know what that does? Anybody tell me what that does? No. So this skates right by request validation because it doesn't know at all what's going on. I mean, this is totally like this is not the cross-site scripting you're looking for. Basically, what those %UFF1C, that is the Unicode version of a left angle bracket. Unicode. What's awesome about that, especially when you're attacking again, it's this .NET, so you're pretty likely going to be landing in a SQL Server database. I think this might work with other DBMSs as well. But if you land that payload into a varchar field in the database versus nvarchar, that gets truncated down to ASCII. And when it gets truncated to ASCII, it becomes a regular ASCII left bracket. And then this gets spit out. I've had a ton of people on like closeout calls go like, how in the world did you get that into our application? Oh yeah, feel free. And so that's some awesome stuff for persistent cross-site scripting. I love it. As I said, browser cross-site, most modern browsers have some sort of cross-site filter, cross-site scripting filter, but they also have some HTTP headers that can affect that cross-site scripting header or filter. So there's one called XSS protection. If you set it to 0, you've effectively disabled the browser's cross-site scripting filter. And I've seen large properties out on the internet actually do this in their server responses. I think Bing or one of the big search engines does this. I don't know why. It's every response that server sends to you. Yeah, it won't do it permanently, it won't shut it down, but for that site, it disables cross-site scripting protections. You know, honestly, I have no idea why they would do that. Unless they're including some code, HTML code into their responses somehow. This is another one, and this is what I was saying, where I have seen this also on a pen test. Basically, what they're doing is downgrading the compatibility filter for IE down to IE7 mode. And so if you have this coupled with it in the trusted zone, that other attack that I mentioned before that's now pretty much dead becomes a completely valid attack because now you're in IE7 mode, and if it's an intranet site, it's likely going to be in trusted sites. Persistent cross-site scripting, again, the browser has no way of knowing whether the code it's getting sent to it actually, it just sees that it's got scripting, and it has no way of knowing whether it's supposed to be there or not. So that's going to bypass that. And then over time, as I mentioned, there's been bypasses. Firefox less than or equal to version 12, this bypassed cross-site scripting filter. Firefox less than or equal to 12, Chrome, this bypassed it. And then IE8 less than 8 and Firefox 12. This one was pretty cool because what you're doing is actually inserting that cookie value. Well, you're inserting a cookie value, but you are inserting that cross-site scripting header into the page through the cross-site scripting, and so effectively disabling cross-site scripting filter, and then you insert script into the page. So as I mentioned, ASP.NET is great. It does a lot of things for you, but where developers get burned is they assume it does everything for you. There are two controls that are used pretty heavily in websites, or at least one of them, label and literal controls, that do not get automatically encoded. Almost every other control in ASP.NET is going to get encoded automatically. So if it's in a text box, if it's in a drop-down, it's going to be automatically encoded. But if it's a label, it will not get. So if you log into an application, you see logged in as Bob Smith at the top. Bob Smith is my username, and oftentimes in my profile I can control what my username is. That's going to usually be vulnerability there. Or I also like to go after search forms. So if I see oh, you searched for test, and it repeats back what I searched for, oftentimes that's going to be a vector for cross-site scripting there as well. Another thing about relying on external protections is web application firewalls. Again, just like the AV, if you have it, it's great, you should have it. I'm not saying you shouldn't have it, but don't rely on that it's going to protect you from every single thing out there. Because another mistake is using the wrong tool for the job. So I had one client one time that was, they were really big into network security, and they employed, oh shoot, now it's slipping from my head, but it's FireEye. They employed FireEye as a WAF. What? That's not a WAF. It was good, it would monitor stuff, but it's not going to protect them at all. The other problem is bypasses still exist. Bypasses do exist in WAFs. When I'm doing a pen test, I ask that our clients whitelist us from the WAF. Because, you know what, I can probably find a bypass, but I'm here to test your code, not your WAF. But occasionally I'll get on a pen test, get into it really quick, and quickly notice that they forgot to, or someone dropped the ball and didn't. I got on one recently that, and sometimes I like to just play around before I go, hey guys, you forgot to, because I like to find a way around it. I was actually doing a pen test and hit an Imperva WAF. Sorry, Imperva, I know you're a sponsor. And found 10 ways to bypass the cross-site scripting filter in Imperva. And this was with the latest rule set. I checked with the client. So yeah, knocked over. So the next approach that I see is blacklists. I love blacklists. When I get on a test and I find that they're using blacklists, it's actually like a puzzle. I like it because I feel like there is a way to get around this. I know it, you know? And so just like I was telling you about getting on with the Imperva WAF, I was like, I know there's a way around this. I know I'll find it. So the basic strategy here is looking for all the bad characters you could possibly have in an input, and then trying to block all those bad characters. The thing is, you have to figure out what is all bad, and sometimes what's bad right now isn't always going to be what's bad later, and vice versa. And these typically can be defeated. So when I see like a blacklist on a test, I look at the test like this, like here's the app, like come at me, bro. And I'm like, yeah, challenge accepted. So I like to look at it. So here's some things I've seen on tests and some ways around it. So let's say this is a very basic. They're just looking for script tags and they're going to block them, right? Okay, well don't use script tags then. I'll use things like input. And HTML5 is awesome. They have this autofocus feature, so I can get to pop like that. I don't even need user input to mess with this. Or I use an image tag, and on error, source equals 1, 1 doesn't exist, on error trips right away, cross-site scripting. I use on mouse over a lot too. I use on mouse over, and I'll use a style tag to say height and width 1,000 pixels, and place it at the top left corner. And so it's basically the whole page, and anywhere you drag on that, it's going to pop. Yeah, I like on mouse over as well. So stripping keywords is also awesome. So what happens if I do that, right? Now it works. Or if it's a SQL injection, it'll pull it out and now become one word for me. I've also seen case sensitivity. Now, this is just crazy. Why aren't you normalizing first? Why are you not normalized? So like this. The most recent one that I saw this on that was awesome is a file upload form. It was a PHP site. I was actually banging my head against it for a while because it looked pretty solid. And then I don't know why I tried it. I was just like, okay, I was kind of at my last straw, so I tried shell and then .php in uppercase, PHP in uppercase, right by it. And file upload my shell to the server. So similarly, in a SQL injection, again, case sensitivity, if they're not checking it, the case. Exactly, there you go. Removing white space, sometimes they're doing this just for functionality, right? It might have some sort of number value and they just strip out the white space just to clean it up or something like that. So if we get rid of white spaces, that's fine. Slashes will work just fine between my attributes. Or if if they're just stripping spaces, I can use new lines and just pop it over new lines, and sometimes we'll bypass WAFs and things like that. Or if it's a SQL injection, start wrapping things in parentheses, get rid of the spaces. No problem. Or I can also use comments in a SQL injection to try to fill the spaces there as well. If they're filtering for brackets, no problem. Oftentimes I'm injecting into an attribute the value parameter, and I don't even try to break out a tag. I'll just stay inside the tag, and I'll just do autofocus or on mouse over, something like that. Or, as I mentioned, I may not be even injecting into a tag at all. I may be in the JavaScript context already. And then, in that case, I don't need any angle brackets. I just can insert some Java, escape out your Java, put some comments at the end to just get rid of the rest of your stuff, and there's my payload. They may be filtering out event handlers. So let's say the WAF is looking for a lot of the common on mouse over, or on error, or on load. They're looking for things like that. So what I've seen in the past sometimes work is JavaScript will accept a space between your event handler and the equal sign. They may be looking for event handler and an equal sign, that and drop it. If I have that space in between those, it may skate right by it. The other thing to look for is, okay, they may be blocking a lot of the common event handlers. Look for weird event handlers then, or HTML5 event handlers that are new, like on ready state change. They may not be looking for that. This one, as I mentioned, kind of hard to exploit nowadays because of the IE11 restrictions, but the expression tag was awesome. Expression tag basically would take any JavaScript and interpret it. The reason why Microsoft, and it's IE only, Microsoft added this in is because they wanted you to be able to have dynamic CSS. So as you scale the page, it would automatically recalculate where elements flowed on the page and things like that. The problem is they realized that that's probably a bad idea, and they dropped this expression. Filtering for single quotes. This is oftentimes what I see on with SQL injection, for example. They're looking for single quotes, and they want to just drop that because they assume that's the only way you could possibly inject into a SQL database, right? And that's partially true. If you're injecting into a string, you're probably not going to break out if they're filtering out single quotes. But what if you're not injecting into a string? What if you're injecting into a numerical field? Well, I don't need to have a single quote in there. So oftentimes when I'm on a pen test, I'm going to zero in on ID values first. Anything that looks numerical, if I'm having a tough time with the strings, I'll go for ID values that try to do that. Or similarly, if they are filtering out the single quote and you are injecting into an ID field, for example, you can still use strings, but just use the char and a concat, and it concatenates that in the ASCII values of the characters, and you can create string values that way as well. And this one's pretty popular out there being exploited right now as well. Again, If you're dealing with something like SQL Server that supports stack queries where you get multiple queries separated by semicolons, this is basically saying, okay, declare a variable, set that variable equal to this basic or hexadecimal encoded string, and that hexadecimal encoded string is your actual SQL injection payload or some SQL statement, for example, and then go ahead and execute that. Again, no single quotes in there, works just fine. And you can execute arbitrary SQL code that way. So a lot of times I also see where they're looking for things like comment. So like for example on the last query there, that dash dash, what that does is just comments out the rest of the query. So if you want to hijack the query, you can comment out the rest of their code and kind of manipulate the query the way you want. In MySQL, the # is also a way to comment out the rest of the code. But if they're filtering that out, sometimes that can be a challenge. And so the way to get around that is you're going to kind of step inside their query and complete it. So if you're in a where clause, for example, you finish out their string and then you say or 1 is equal to, and then you have some sort of true-false statement, like user, the currently logged on user is SA. Okay, return 1. If it's not, return 2. And that will cause the query to either fail or succeed, and then you can know by the results whether your question you ask basically the database is true. Or if they're just blocking keywords sloppily, sometimes not. So they may be looking for a whole script tag, like the start and the close, and if they see that, then go ahead and drop it. I've seen where if you don't complete the tag, what happens is the browser will see that and go, hey, wait, you forgot to add the end tag. I'll go ahead and add it for you. And so it helps me out and goes ahead and adds the ending script tag, and the payload is successful. Actually, even without that, it's still successful. It'll still work. Another one that the browser helps us out on is the ending bracket. So if they're looking for paired brackets for the tag, if I don't add the ending bracket, then the browser will help me out and add that for me as well. This one was hilarious. Again, getting on a test where the client insisted that they had whitelisted us from their WAF. So I get on the test and I put in script, alert, script, and it throws this big fat error at me. And so I found that I could put in script with a space before that closing bracket on both sides of the thing, and it would get right past it. So I called the client up. I'm like, hey, dude, come on, whitelist me, seriously. It was funny the first time. And they're like, you're already whitelisted, you know? And the client, like, my point of contact, which was like a VP at the company, he was like, well, I can't make it to this meeting, but I guess his buddy, who's his subordinate, goes ahead and calls this meeting to try to figure out why is he getting blocked, you know? And so we get on the call. I send him my payloads. I send him like screenshots from burp repeater, and I send him my IPs. Cool. Hopefully they're going to whitelist me, right? No, my boss gets a call like at 6 o'clock at night from my point of contact, the VP, like railing, completely going off the handle, like, this guy doesn't know what he's doing, how long's he been pen testing, you know, just totally laying into me. I want him off this test, I want all the money back for all the hours that he spent on this, and it turns out it was built into their application or something, so we're kind of both right. But it was kind of vindicating that like 30 minutes after I get off the call with them, I found like unauthenticated SQL injection, and like they're a credit card processor also. I was able to like pull credit card numbers up and things like that. So I was like, okay, you know, so I was like, okay, maybe he doesn't know what he's doing. Oftentimes too, and this is really dumb, I see like alert. The alert function is blocked. You're not doing yourself any favor when you do this. All you're doing is breaking your automated scanning tools. That's all you're doing, because I can use confirm or prompt for my proof of concept, or I can use some completely different JavaScript. Some think they're clever. Again, I've seen also some looking for that expression tag that we talked about. Well, since the expression tag is inside some CSS, I can put comments wherever I want in strings, and it won't matter, and I can break up the string this way. Or using weird tags that like almost no one ever uses, like SVG. I also love this cross-site scripting payload because it's so small and fits in a lot of really crammed places. You can even shorten it down by dropping out the quotes and making like alert 1 or something like that, and even dropping the last bracket off to make it really small. But that's a good one. Often gets by. Another one is math. Who's ever heard of a math tag? What the heck is that? But it operates like an A tag, but this works as well, and this has the position absolute, top 0, left 0, 5,000, so it's going to fill the page. They click anywhere on the page, they're going to get exploited. Another one here is using HTML encoding. So again, we're inserting into a value statement. We're not even trying to break out of the tag, so by putting it in HTML coding, you're not even going to see what I'm trying to execute. This is also a great technique if they, again, for not necessarily trying to stop you, but let's say they change everything to uppercase, so like caps, like your name or something like that. This is great because JavaScript is context or is case sensitive, and so if you have an alert function and it's all uppercase, it's not going to work. So this is great to encode it here like that. Another neat trick for that, if they put everything in uppercase, is use a script tag with a source attribute, and you're pointing it out to some external site, because that can be all caps and still get by. Similarly, again, keyword blocking, object tag. This is another one that just skates by a lot of filters, and your payload is then base64 encoded in that value, and you can put whatever JavaScript you want right there. As I mentioned, character set is important. If your site is not UTF-8 explicitly saying that at the top, you can insert UTF-7. And oftentimes, things like UTF-7 are going to go right by your filters. This is an example where your actual payload contains a tag forcing the page downgrading into UTF-7. And then your payload there is in UTF-7. Another one too, if the filter is looking for like union select, which is oftentimes what they're doing, union all select will get by it. Union all select, I use that as a de facto anyways, because union all select will also get by a lot of type casting problems, because you're trying to kind of append some results from the union onto the regular query, and if you don't know the character type of each column of the query, you may have problems there, but union all select will do some magical conversions for you. Another one, just like the alert pop-up box, is they're doing things like blocking 1 = 1, because oftentimes that's the classic SQL, right? Tick or 1 = 1 --. I've seen this, no joke. Blocked. 777 = 777, that's true, right? It went right by it. Like, seriously, man, come on. Or I've seen ones where they're actually blocking the equal sign. They're looking for the equal sign. Okay, fine. A is like A, right? It is. Or similarly, as I mentioned, a way to get past request validation was splitting across multiple tags. This is another strategy if you break it up across multiple parameters. So my SVG part is on this side, onload is over here. A lot of times this type of thing would be like your first name, last name up at there, that you are logged on as SVG, and then last name onload, and it will pop it. So, I mean, there's just so many ways to just get by a lot of this stuff that blacklisting just is ridiculous, and you shouldn't be doing it, because we'll get by it as pen testers. We're creative, we're tenacious, and we will break it. It usually takes several iterations before we're finally like, okay, we can't get by it yet, but maybe someday. So really, the next approach, and this is the approach I'm really kind of saying this is what you should be doing, is whitelisting. And basically, this is the opposite approach. Instead of trying to enumerate every single bad character, bad piece of input into your application, you know what kind of input should be going in your application. You know a social security number should contain numeric values and dashes, and it should be, X number of length, and, email addresses are of a certain format. Names shouldn't contain left brackets and angle brackets, crazy stuff like that. Unless, maybe I'll name no, I don't have any kids left. I already had all our kids, so. But that would be cool, kind of like the Bobby Tables thing. I named my kid that. I could name my kid left bracket, and then, never mind, I digress. What's that? No, I like that. Yeah. Yeah, then they try to insert it into some database, and they don't allow null fields or something like that. Yeah, so whitelisting, you're basically just looking for what you know to be good for that application, and oftentimes this is going to be employed in using regular expressions, basically patterns like I showed with the when I was describing or the representation of how request validation works. Like I said, there's also a lot on the internet. If you go look up, people have written out big, long regular expressions for certain things like phone numbers and social security numbers, already kind of pre-canned, so it makes it pretty easy, because sometimes regular expressions can get unruly. Sometimes, right? You wrote a regular expression, now you have two problems. So regular expressions, they can be used to verify the input that you're bringing into them, to check them. Again, this is another thing that ASP.NET does very well. It's built into the code. Not only does it automatically encode, but you can also include in your tags, you can say it has to match this format, and now it'll start rejecting things that are not of that format. It's basically just a string of meta characters, and I'll show you some examples that how many people here are familiar with regular expressions? Oh, okay, well then. Yeah, so I've actually gotten pretty good at them lately. I had to do a big project where I was writing a ton of them, and it got pretty decent. So then you're probably familiar with kind of the layout. Who's used Burp Suite before? Yeah, so you need to know regular expressions use Burp Suite. Like your targets list, you're going to have to put in targets. It's going to want regular expressions. Or if you do searches, it's very helpful. So the caret bracket is representation of saying this is going to start at the first character of the line, or the beginning of the line, and match until the $ indicates the end of the line. And dot is basically saying any character possible. And then brackets are basically like a set of characters. So bracket A is going to be A, B, C means A, B, or C. A through C is also A, B, or C. And a hyphen is basically treated as literal unless it shows up in between multiple characters. Otherwise, you need to put the slash to kind of escape that as well, just like JavaScript. If you have that caret inside of brackets, it means not, so it's a negating feature, basically saying not A, B, C. And you can also represent hexadecimal values with the escape character and X and then the code. B indicates that it's bounding a word boundary, so it's looking for white spaces on each side of the word. And then question mark is basically saying it can exist or it cannot exist. Star is going to say, again, 0 or many times, and plus is going to be at least one time or many times. So just some examples again. .at means it could be any character, and then it could be at. HC at, cat or cat, not B, so it can't be bat. Alphanumeric words. As I mentioned, people have figured out all these regular expressions, and you can kind of go get them, because some of these look really gnarly, like that phone number and email addresses. I think the very worst I've ever seen, if you go Google it, because there's so many people who think they've got it right, is URLs. Go look for a regular expression of a URL. It is awful. It is so bad. If you actually write a regular expression that follows the spec, it's pretty bad. So here's an example of using regular expressions, but using them as a blacklist. Basically, you've got all these characters, and you're saying, not any of these characters. Well, again, blacklisting, the problem there is, what if tomorrow, after you've written this, another character is discovered? Now you got to go update all your code and figure out and put it in there. This is also a lot, pretty big. So here's the pattern that you're looking for. You're looking for not all of these characters, and it actually gets pretty complicated. You're looking for all these bad characters. Here's the same thing, but in a whitelist format. So you're saying it has to be these. It has to be alphanumeric or digits. So it's less complicated. It's more reliable. It's harder to make mistakes when you're doing it that way. As I mentioned, ASP.NET is good that it includes this in the standard already. And here's an example of some ASP.NET code that does validation on a username or a name field. It's basically alpha characters, a dot, a tick, or white space, and 1 to 40 characters. Same example, but with Java. If you're a Java programmer. Or PHP, same sort of thing with PHP. So OWASP, I know there's some of my fellow OWASPers here. Who all's in OWASP? Show of hands. I highly recommend that you get involved in OWASP. Your job may not entail application security, but application security is just a booming, growing field that seems to be touching even outside application security, into network security, and there's all these different things, because it really all comes down, like I said, input validation problems. There's 2 really good projects going on with OWASP, Anti-SAMI and ESAPI. I actually had an opportunity to work with Anti-SAMI on a large-scale project. It was pretty cool. That's where I really got pretty good at regular expressions. Essentially, a large internet retailer had approached Trustwave and said, hey, look, here's the deal. We're writing this new website, and the problem is that we've got this marketing company that wants to look at stats from our site. So it collects stats from their site, and it pre-builds section of the code like suggestions, like, hey, other people are looking for, this, that, and the other. And then it ships us back this chunk of HTML code. How do we know that the HTML code is not malicious? How can we know that JavaScript isn't inserted in it, cross-site scripting, or something bad is in there? So that was the challenge that I had to face. So what I did turn to Anti-SAMI. Basically, it's a policy. You write a policy for it. It's got some API. They were using Java, so we did a Java API. But you basically feed it in this XML file that's a whitelist of all possible tags, all possible attributes, and even regular expressions of the values of those attributes that you want to allow in your file. And it goes and parses the file and flags, or actually strips out anything that doesn't match what's in your XML policy file. They were pretty serious about this, so they actually said, we're not even going to strip. If it gets an error even once, we just drop the whole packet, and we'll live without the results. So that was a pretty cool project that we got to use. ESAPI has some similar features. It's got a whole lot more type of validation and scrubbing techniques as well. So highly encourage you guys to check those out. The last approach is exact match. This is pretty simple and obvious why this is the best policy, but it's pretty rigid and oftentimes unpractical. But it can work in some scenarios, like states. You know all the state names. We're not going to get any new states. So just, unless Texas defects, then we can get it out of the list. But yeah, Puerto Rico, zip codes. Things that have finite values. You can enumerate all of those, and you can just put them in and check against that list. That's the highest level of validation. But again, it can be time-consuming, difficult to maintain, and but it is the most secure approach. So basically, if we take that and we put it all together, right? So how do we want to secure this thing? Something I'm calling the magic sandwich. We're basically going to take all our input. We're going to validate it all. We're going to check type. We're going to cast it. We're going to check the length and bounds and all that. And then we're going to whitelist it against what should be our expected input. We're going to use that input in our code. And then we're going to validate on the output. So check it again. Even though it's coming from your database and you should trust it, you shouldn't trust it. Check it again on the way out, and encode it on the way out. And anything that you find that's bad, that doesn't match any of your rule sets, drop it on its head. Just get rid of it. You should never try to scrub it or get rid of stuff that doesn't look right, because again, you're falling back into the blacklist approach. Inform the user of the error and drop that input. So at this time, I'll take any questions you have. I can make the slides available. I haven't heard from CircleCityCon what they're going to do about that, so I can definitely make the slides available for you. Any other questions? No? Okay. So we have some tools on our Spire Labs GitHub site that a friend of mine wrote that helps you kind of play around with cross-site scripting, SQL injection. You can try out bypassing some of the protections. It's nice because they're configurable, so you can like tweak how much protection you want. We've got our latest global security report up there, blog posts. Occasionally I post on there, and then we've got our Twitter account. And then here's my contact information again if anyone wants to hit me up on Twitter or email me. I can get you the slides that way if that's what you like. Other than that, that's all I got.